Here we have an example of a permutation. We'll do it by hand and we'll do it by calculator. Now remember, guys, a permutation is used when the order that the objects is chosen matters. Here's our example. At an annual college science conference, student presentations are scheduled one after another in the afternoon session. This year, 5 students are presenting in biology, 5 students in chemistry, and 2 students in physics. A. How many ways can the presentations be scheduled? Let's take a look at that. They're looking at presentations in whole. So we have 5 biology, 5 chemistry, and 2 in physics. So we have 12 presentations that are going to be scheduled. How many different ways can this happen? Well, the order of the presentation matters. One chemistry student is different than a different chemistry student. So we are going to use permutation. 12 people are presenting, 12 are available, and 12 are presenting. So here is how we would solve it. If we did it by hand, remember n is the number you have total, and you're going to divide it by the number you have minus r, which is the number you want. In this case, it's the same. 12 factorial divided by 0 factorial. Going back to algebra, you think, oh my, I can't divide by 0. But 0 factorial, how many ways can you arrange 0 things? Well, you can do it one way, and that's 0. So basically, we have 12 factorial. Go over to our calculator. 12 we'll do it this way, 12 permutation 12. Pretty large number here. 479. There are, get our commas in here, 479 million different ways you can organize those 12 students in presentations. The possibilities seem endless. Now, we did that one. Part B, how many ways can the presentations be scheduled so that each subject is grouped together? Now, this one's a little different because we have 3 different subjects. We have biology, we have chemistry, and we have physics. We have 3 categories of classes, biology, chemistry, physics, and we have the people or the students within that group. So there are 5 biology students that can be arranged, or order matters, because each arrangement would yield a different schedule. We have 5 chemistry students, and we have 2 physics students. So if we go over to the calculator, we'll clear this, and we'll go 5. Whoops, permutation 5. That's not permutation. The other one we need is a 2. Permutation 2. So we have 120 times 120 times 2. And that yields an answer of 228,800. However, we only calculated the possibilities if biology went first, chemistry went second, and physics went third. That's not what they said. They just said the groups have to be together. So we're not finished. We figured out the possibilities for the first option, which is biology, chemistry, and physics, but we need to think about all the other different arrangements that could happen. Chemistry could go first, physics could go first. And how we would do that is we have three, let me switch colors for you. We have three groups. We want to know how many ways can we arrange those three. If you do that calculation, end up with 6 different ways. So we need to tie these two together. 6 times 28,800, 172,800 ways we could schedule the presentations that each subject is grouped together.